This is for Year 12 Methods. It's the 2011 Functions Application Tech Allowed SAC, and it's question number 7. The vertical height in metres of the seat in a Ferris wheel is modelled by this function, where t is the time in seconds from the instant that the chair is at its lowest point. Okay, so we might just come over here and graph it for starters. And I have minus 6.5 cos, so math trig cos pi x divided by 30 close bracket plus 7.3. Execute. Period will be 2 pi divided by pi on 30, which ends up being 60. So with my window I'll go from 0 to 60, which will give one complete revolution, 60 seconds. My minimum is 7.3 minus 6.5, so I'll put that as being 0. My maximum is 7.3 plus 6.5, which is for 13.8, so I'll maybe say 15. And there's what one complete cycle will look like. State the period of revolution, 60 seconds. State the amplitude is 6.5 meters. And sketch a graph for 2 revolutions. I'll go out to 120. And an acceptable sketch of what that looks like in this space will be okay, making sure you label the endpoints. So analysis, G-solve, and I do y-intercept, and that gives me 0.8, and you'll find that the endpoint will be the same, analysis G-solve 120, y-calc when x equals 120, also gives 0.8. So we sketched 2 revolutions. The times to 2 decimal places when the chair is 10.4 meters above the ground. So analysis G-solve the time, so x calculation when it is 10.4 meters above the ground. The first time is 19.747439, and I need to do this to 2 decimal places. So it's 19.75 seconds, and the second time is analysis G-solve x calc when that's 10.4, and to move across don't know why that's doing, so 10.4, draw both lines, analysis G-solve intersect, there's the first 19.74, there's the second one, 40.25. And that's how many seconds in the first revolution. For how many seconds during the 2 revolutions is the chair more than, okay, so I've got to do, that's 79.75. And lastly, the last one is 100.25. That's the 4 times, and it's 10.4 in the 2 revolutions. How many seconds during the 2 revolutions is it more than 10.4 meters above the ground? Okay, so I can go into main. For how many seconds in the first 2 revolutions? 40.25 minus 19.75 is 41, and I want to know how many times it's above. I'll have a little look at the graph again. It's above for those many seconds, so that's how many seconds, 41 each time, so times it by 2, so 41 seconds is the answer. Okay, now the wheel has changed its speed and the height of the chair is modelled by n of t, which is h 3/5 t. Describe this transformation. If I replace t with 5t divided by 3, therefore it's a dilation by a factor of 3/5 from the y-axis, which means 3/5 is less than 5, so it's a squashing towards the y-axis. What is 1 period of revolution? Well, it's going to be 3/5 of what it was before, so 3/5 times 60, which is what 1 period was before. So if I do 3 divided by 5 times 60, I should find that it's now 36. And what's the rule for the function? Okay, so I go back into main, go into graphs and tables, and I take a copy of all of that. Edit, copy, go back into main, keyboard paste, and if I define that, that's what f of x is. F of x is this, therefore f of 3x or 5x on 3 should give me that, and that's the new rule. And that's it.